All right, guys, here's Mr. Lamb coming back with questions. Really just that last question, 6, but it's A, B, C, D. This page is worth 9 points. Part A is worth 3 points. Part B is worth 2. Part C is worth 2. And Part D is worth 2. And all of it's based on getting the right answer and having the right justifications. And then Part A, obviously, if you show the slopes and distances, I give you a point there in that part. Without further ado, LM and O, I went ahead and plotted them. They're plotted graph, lines are drawn, all that good stuff. And Part A says, is this thing a parallelogram? All right, now there are several ways to do this. You can do this by finding distances. You can do this by finding slopes. You can do this by doing a combination of slope and distance. Personally, I'm going to do this one by slope. If you did it by a different means, by all means, you can come see me and we can talk a little bit about whether your answer is right and why. So, as I look at this figure, this four-sided figure, if sides are going to be parallel, it's kind of easy to pick my top and bottom and my left and right. I like my top and bottom here to be LM and ON. Right, so it's kind of my top left and my bottom right corners because it's sitting diagonally. Looking at this thing, it's pretty easy to tell that it doesn't look like it's a square. It really looks like a rectangle, though. I don't know yet if those slopes are going to be rectangular or not, but I'll find out. So let's go ahead and start up. Let's go with LM first. So segment LM. So if I want to find the slope of LM, from L to M, it goes up 1, 2, 3, 4. And it goes to the right, 1, 2, 3, 4. So the slope here is 4 over 4, rise 4, run 4, which reduces to positive 1, or 1 over 1. All right, I'm going to do the same thing for segment ON. All right, that's the one that I think is going to be parallel. So O to N, it looks like it goes over 1, 2, 3, 4. That's good. It's a number I've seen before. And it goes up 1, 2, 3, 4. And that's good. So my rise is 4. My run goes to the right 4. So 4 over 4 is 1. And we have talked at length about what is parallel. So these two segments here both have the same slope. They're both positive 1. So these two things are parallel. And remember, if you want to think of these as fractions, you can think of this as 1 over 1 if you want. So that's good. That's my first pair. So now I'm going to check my other pair. I'm going to check LO and MN. All right, so LO. So from L to O, it's going down 1, 2, 3, 4, 5, 6, 7. That thing goes down 7. And it's going right 1, 2, 3, 4, 5, 6, 7. So the slope is down 7, negative 7, right 7, positive 7, which is a slope of negative 1 over 1. It is negative this time instead of positive. All right, from M to N, it goes to the right 7, and then it goes down 7. So, rise over run. The rise, it goes down 7, I said, and it goes right 7. So, negative 7 divided by 7 is negative 1. All right, comparing these two slopes now. Opposite sides, that's what I'm looking for. Negative 1 and negative 1, they are the same. That means these two are parallel as well. So, unlike on page 1, here I have two pairs of opposite sides are parallel. So the question, is this a parallelogram? Yes, because both pairs of opposite sides are parallel. That's why. Now, you could have said LM and ON find their slopes and then find their distances and said that one pair of opposite sides are both parallel and congruent. Okay. You could have found the distances of these four segments and said both pairs of opposite sides are congruent. Okay. I don't care which of those three methods you choose as long as you picked one of them. All right. Now, I want to make sure that I'm really staying focused on this concept of slope in part B. Because in part B, I need to look at the slope of one corner. And I don't care what corner it is. All right, I'm just going to pick a corner here. And I'm going to pick this corner right here. You'll see it in orange. All right, that's the corner I care about right now. So LM, and I can see that my slope at LM was 1. So again, remember, I'm looking at still at slope. So I'm looking at segment LM and I'm looking at segment LO. And segment LO, you'll see up there, it was in blue. LO had a slope of -1. Well, here's what's great about the ones. All right, as I compare these two slopes, are they opposite? Yeah, one is positive and one is negative. Are they reciprocals? Well, 1/1 has a reciprocal of still 1/1. So these are opposite reciprocals. So these are perpendicular. So these things are perpendicular, which is really, really handy for me. Whoa. Oh, well. That means a lot, because if these things are perpendicular, then the question, is this a rectangle? The answer is yes, because there is a right angle. And we know that by definition, if something is already a parallelogram and it has a right angle, then it's a rectangle. So yes, this thing is a rectangle. All right, for part C, determine if this thing is a rhombus. All right, in order to do that, I need to find distances. All right, so I need to find distances. So here we go. The segments again that I was looking at in red, what were they? LM and ON. And then in blue, they were LO and MN. All right. And remember, distances are always, and really what I can do is, I know that it's a parallelogram. So the opposite, the parallel sides, I already know they're congruent. So really, in red, instead of finding them twice, I'm just going to find one of the distances, if you're okay with that. The red distance, so the distance in either one of my two red ones, the legs of those two triangles are 4 and 4. So I need to do 4 squared, which is 16, plus 4 squared, which is 16. So the distance of both red segments is the square root of 16 plus 16, which is 32. Right, my two blue sides, LO and MN, it's parallelogram, so I know that they're equal. But they are the square root of, those triangles are 7 by 7. So 7 squared is 49, plus 7 squared, which is 49. And I add 49 plus 49 together, and I get 98. So I have two sides that are radical 32, and I have two sides that are radical 98. So the question of, is this a rhombus? The answer is no. Why? Because not all four sides are congruent. You have to have all four of the sides the same in order for it to be a rhombus. So is it a parallelogram? Yes. Is it a rectangle? Yes. Is it a rhombus? No. And that makes part D real easy. And we did a really good job on this one. I was happy with this one. Based off of your results in B and C, is it a square? And it is a rectangle, but it is not a rhombus. So the answer is no. Why not? Because it is not a rhombus. It has to be both a rectangle and a rhombus in order for it to be a square. So that's it. Hopefully you got something out of these videos. If you want to schedule a retake, let me know. If you have any other questions, please feel free to let me know. Have a great night, guys, and I'll see you in a couple of days.